I almost succeeded to convince myself that I can find the closed circuit or the short that's causing a problem. As you can see, I labeled every electric outlet by the number of the circuit breaker on the main circuit breaker box. So that was line 13 and 12. That has no number yet, which means this is a problem. I cannot find it so far, but I did. When you switch it on, you have no lights. When you switch it off, you have no lights. So this is the first part of the line, that the circuit line that's causing the problem. You can call it the circuit. This entire room has a problem. You turn the lights on or off, you get no lights. So what I did, as you see, I opened all the plugs, the electric outlets, take the cover off and measure the resistance. I left this one because there is no need for it, it's the same one. I broke that apart, that electric outlet apart. Here you have 4. That's 1, that's 2, that is 3, and that is 4. And the electric switch doesn't work. That doesn't work. You turn the light on and off, doesn't work. There is no number here because I cannot trace that to the circuit breaker yet. But I kind of know where that circuit is located. So we'll return this back to its position. I will show you. I did that in a previous video. What you do is you measure the continuity or the ohm between the black and the white. And you turn the switches on and off as I did now. So I will go to the other plug, that is electric outlet connected to the same circuit. We said we have 4 in the other room. This is just a wall separating, and you have another electric outlet here that's still not working. And it has the same problem that I will show you in a minute. Here, everything is numbered. When it is numbered, it is traced, which means if you turn that off, the light goes off. If you turn that on, the light goes on. Okay, so this is already numbered, traced, identified as number 14. This is number 14 circuit breaker 14. This is 14 and this is 14. So all these are identified and traced. This is traced to number 11, circuit breaker 11. This is traced to another one, but the problem here is solved, so I leave that for now. This is traced to number 16, circuit breaker 16. This is circuit breaker 19. This is circuit breaker 2 and 3. So everything here is not a problem. This is not a problem. 11 and 4 identified. This room is not the problem. This is not the problem. This is a problem. So here we are working on this one. This is circuit breaker number 4 identified. Well, here is the problem. Now, you can convince yourself the way I convinced myself that it is real. The problem is real. You come to the switch, you turn it on or off, the light doesn't go on or off. So the problem here, there is no number here. Here is, that will convince you. This will now plug electric outlet number 3 that I was able to test the continuity of the ohm before and after the switch is off. This is a wire. This is another wire connected here to the red and the black of the ohm meter. The ohm meter now reads, this is the ohm as you see. It reads open circuit, which means infinity. because if you connect any of these wires, it will stay this way, open circuit. And we are going to go back to turn a switch in the same circle. If you turn this one switch on, let me see. I did. So which one of these? Well, here is the situation. I am going to turn my finger and I'm going to look at the ohm meter right here. There is a transient tree. Look at that. So we are going to leave that now. There is some kind of connection or a short here, but we have a definitive short. We are going to the bathroom and see the short that will make the continuity permanent, and you are going to have a fixed reading. Is not going to go on and off. And all this is already identified as number 15. So this is not a problem. There is a plug here, not a problem. All these rooms are not a problem. We go back here to find the culprit. The culprit is, and turn, this is a bathroom, this is a secondary bathroom. We turn it, we switch that. We go back again to read. We are measuring on one circuit only, not all the circuits. This house has 21 circuits. Each circuit is designated to a certain part of the house. For example, here is the porch is designated as circuit number 1. That circuit number 1 is connected to this circuit number 1. So after you number the electric outlet and you trace them back to the circuit breakers, and you find out a group of electric outlets and the lights that are not identified, that is your circuit. Here, I turn the switch other way. You have a fixed reading, 1700 ohm. 1700 ohm on this electric outlet. If I go back, turn the switch the other side, you are going to have here infinity, which means open circuit. So we will go back. We will repeat that process because you need to have a definitive causation, not just a guessing. Because if you are not good in electricity, if you are not trained to measure the continuity and the volt and the current, two different measurements, two different connections. Continuity you have to measure between the two terminals of the same circuit to see if you have continuity or not. Turn the power off. We are going to switch this other way and we will go back and repeat. When I go back, the reading have to be infinity because I cut the short. I removed the short by turning the switch off. And the short is in the attic. I have to go up in the attic and separate the wires from each other and locate where the wires are touching. Now, I am walking from the bathroom to the garage. And here you are going to have a reading infinity. And you are going to say, wow. Here is infinity. You can say now, wow, we already figured out where is the culprit. When I go outside there are 3 electric outlets. 2 of them are not working. But before we do that, we are going to repeat the same process on this circuit that's not identifiable. I will get another terminal that belongs to this circuit. We are going to repeat it again. That is in the garage. Here is the garage. And here is the wire that comes from the top. We take this wire. This circuit is isolated, which means it does not have power in it. So we just got it inside the room, which can turn the door, so we keep the heat out. There's enough room. This wire belongs to the same circuit that I brought from outside. So I'm going to connect the black and the white. I will take those black and white from here. Connect them to this wire. Take that one from here. When you open it, it is an open circuit. Because I still in my hand, I did not connect it yet. We connected here. It did not read, which was supposed to read, which might tell me it's supposed to read something. Which tells me this wire might be causing problems upstairs. Because it reads infinity here. We will go back. Let me turn that switch on and off and see if that will change. It does. Look at that. It does, which means it doesn't mean anything now. First, we connected this wire to the ohm meter. This wire belongs to the same circuit, but I brought it from the garage. It's causing problems. So we are going now to turn one of the switches on and off and see how this wire is, which wire is checking the continuity of the circuit, the wire in the circuit with no voltage applied to them. We talk about how to measure the continuity when there is no voltage. When you put voltage, you have to make sure you are measuring the continuity between different potentials. For example, you measure between the white and the black. This is white and black. You cannot measure between the black and the black. You cannot measure between the white and the white. Ohm. We turn that the other way. And we will go back to the measurable line to see if we switched the continuity. So that labeling process, it was not on the top of my mind. It is an idea that developed over so many weeks, days. I have a job to go to. So when I run into problem, I just leave it for another week, another day, and sometimes another month. So every month you come up with a new, wow. Look at that. So these two wires here, this wire here is also affected by the switch, which means we have a short, which means few wires on the attic. Few wires are touching each other, such that when you turn the light, when you turn the switch on and off, they are not supposed to affect the continuity on the outlet. It's supposed to be between a neutral and an active only, because you are using that to power a device. If it has continuity, you are going to have fire. You are going to have a drain. We go back to the same switch, and this will be the last one before the end of this video. At least I showed you that all the electric outlets are numbered, are assigned to circuit breakers, and I was able to exclude a circuit to trace it back For example, this room is already identified. The number here is 15. The bathroom has two lines, two circuits. We are going to turn that switch on and off for the last time. And we will go back before we take a break for the day. Have to go to work. And I'm going to work happy because I am convinced that the problem is identified. Now, I am not there yet, but I can tell you it is an open circuit, which means the reading will be infinity or 1. And we come here, now you are convinced.